Hi everyone, I am Shubham Garg and welcome back to the lecture series of Tanner. So in today's video, we are going to see how to do the power analysis of a circuit, that is how to calculate average power, maximum power, minimum power in a circuit using Tanner. Alright, so we have made various schematics using SRED, we have simulated the schematics. However, we have not done power analysis till now in any of the circuits. So in today's video, we are going to see how to perform that power analysis. Okay, and we can apply the same technique to any circuit to perform that power analysis and get the values of power consumed. All right, so first of all, let us start with this edit. Here we have already seen how to make the inverter design using SEdit and how to simulate it. So I will just for once I will simulate the design and show you the waveform. So just click on this button, and before that remember to set up and perform the spice settings and everything. You can watch the previous videos for that. Alright, so it is simulating. Now here you can see we have the waveforms, that is the output, input and the output. That is the input voltage and the output voltage. We have the waveforms. Alright, so that means our design is working. Now let me tell you something about this, that we can see there is this T-spice window that always pops up if our simulation is correct or if there is an error. Okay, so basically this contains all the information, that is all the output information, and here only on this file only we will get the power. Okay, that is the power consumption details we will get here only. Alright, so let us see how to do that. First of all, what we need to do, first let me tell you something, that there are two sources in any circuit. First of all, this input voltage, that is V1, that will be there every time, and then there is this VDD, all right, which we have defined as V2. So these two will always be there. Okay, and we basically we need to calculate the power at the input and the output, all right, for the power consumption. So what we need to do is we need to add a plot, that is we need to go to spice plot, and you see the way we added a plot here, that is print voltage. We need to add another plot for power, that is POW. Just write POW and you will see there is POW underscore voltage source print. So just right click that and create instance. Okay, paste one instance here and another instance here. Okay, basically you can place anywhere, it won't matter. And now you can see here there is this print voltage source power, and it is by default V1. Okay, so what we need to do is we need to change its name to VV1. All right, and that is for the input. Similarly, this thing, print voltage source power, that will be for V2. So we will change the name here to VV2. Okay, so now our names have been changed. Now let's save the design. Okay, now what we need to do, first of all, let me run the simulation at this point. So when we start simulation, you will see there will be the power plots. All right, that is the plots for input power and the output power, which will be plotted along with the input and output. All right, so let's just run the simulation. So now you can see instead of two plots, there are four plots. All right, that is input output, input power, output power. Okay, so there are four plots, and now however what we need is we need the calculated values. All right, although we can calculate the values by reading the graphs as well, but we need that already being calculated. All right, so for that just close this. What we need to do is we need to go to this T-spice, that is T-spice folder, T-spice icon, this purple icon. Just click on open in T-spice and you will see your design will open in the form of a spice code. All right, so basically that is what when we say spice simulation, that is what gets simulated. So we will see how a spice code looks like. So here you can see this is the spice code. There is all the information about your design. Okay, and this is the library file that was included before, that is when we include this generic 250 mm file. 250 nanometer file, and we write as space-ct. So basically what we can do, we can either include the files the way we are doing till now, or we can directly even write the tSpice code. That also works. However, for the ease, I have taught you from going from spice simulation and adding the parameters. Now you can see everything, every parameters and everything, all the plot probes we are adding, the transient analysis simulation settings that we have added in the spice settings. All these are there in this spice code. All right. So now here we are going to add a command to plot power, that is .power. Okay, you can see it turned blue. That means our command is correct. So we need to write .power, and here the source name. So here we will be writing VV1. Similarly, we are going to go do it again, .power, and that will be for VV2. All right, so we are going to save, and here we are going to run the simulation. Okay, so it will ask for output already exists. Just click yes. We wish to overwrite. Okay, and we can see in a few minutes it will show the power calculations as well. So you can see there are all the 4 plots, and here you can see these are the power results. That is power of VV1 source from time 0 to till the time the simulation ran. Similarly, the results of VV2 power. So there is the average power consumed, max power consumed, minimum power consumed. All these results are there. All right. So this is how you do the power analysis using Tanner. Okay, I hope you can apply this thing to any of the circuit, because every circuit has the input source and the output source. Okay, so this is how we do the power analysis of any circuit using Tanner tools. So this is all for this video. See you guys in the next video.